Okay, so let's look at the subtraction of complex numbers. In my previous video, I discussed about the addition and introduction to complex numbers. So let's now subtract. How can we subtract complex numbers? So for example, if we have these complex numbers here, they're saying subtract the following complex numbers. So we have 10 plus 2i, subtracting it from 14 plus 5i. In number 2, we have 8 minus 3i from 4 plus 7i. Remember, in my previous video, we discussed to say this is the real part and this is the imaginary part. And we said upon addition, we add the real part. So even subtraction, we subtract the real part with the real part and the imaginary part with the imaginary part. So to do that, we first need to use this method, which says you let any letter of your choice, for example, I've used z, to be this first complex number, and then z is equals to the first complex number and w is equals to the second complex number. So we are subtracting this complex number from that one, meaning it is 14 plus 5i minus this complex number, which is 10 plus 2i. So yeah, since this one is w and this is z, then w minus this z will be this w, which is 14 plus 5i in brackets, minus z, which is this one here, 10 plus 2i there in brackets. So after that, you open the brackets and subtract the real part with the real part, and then the imaginary part with the imaginary part. So to do that, we are going to open the bracket first. So if you open the bracket, negative times that 10, it will be negative 10, and then negative 1 here times that 2i, it will be just negative 2i. So after that, now we group the real part with the real part and the imaginary part with the imaginary part. So we're going to have 14 minus 10, and then this 5 to be minus 2i there. So to do that, we are going to have our difference here. 14 minus 10, it is just 4, and then 5i minus 2i, it is 3i. So that is the difference of those two complex numbers. So the answer for the first question is 4 plus 3i. So instead of you opening the bracket here, you can use another method. You can just go direct. Okay, just go direct. You say 14, which is the real part, minus the real part here, it is 10. So you're going to get a 4, and then 5i there minus the imaginary part that side to be 3i. So you get the same answer, but it is good to go step by step so that you don't make mistakes. So let's go for question 2. Question 2, they are saying we should subtract this part here, this first complex number, which is 8 minus 3i from 4 plus 7i. So we do the same. We say this is the same as z and this is the same as w. So our w here minus our z is going to be our w, which is 4 plus 7i minus z, which is 8 minus 3i. So we do the same. We subtract the real part with the real part and the imaginary part with the imaginary part. Okay, so either you say 4 and this one, which is there, negative 8, in the same bracket since they are real parts, and then 7i and 3i there. Here it is going to be that negative multiplied by that, then it will be a positive in this bracket here. So 4 minus 8 to be negative 4, and 7i plus 3i to be 10i. So the answer for the second one, it is negative 4 plus 10i. Okay, so instead of you going through these methods, you can also just go direct there. You say 4 minus this 8 here, which is the real part, so it will be negative 4, and then 7i minus negative 3i. So this negative, when that negative, it will become positive, and it will be just 10i. Okay, so that is subtraction of complex numbers. But let's also look at powers of the letter I of the imaginary numbers. So what we know already in my previous video is that our I is equals to the square root of negative 1. This letter I here is simply the square root of negative 1. So if we square both sides, we get our I squared equals to negative 1. If we square here, the root will go with the square, and we are going to remain with I squared equals to negative 1. But if we multiply both sides of this equation with I, then this I squared will be I to the power 3, and this negative 1 multiplied by I to be just I, meaning I to the power 3 is equals to I, negative I. So again, if we multiply with another I, or rather if we say I to the power 4, it will be, to simplify I to the power 4, we are going to say I to the power 3 multiplied by I is the same as I to the power 4. So this I to the power 3, we saw there, it is just negative I, and then I multiplied by this other I, we are going to get negative I squared and negative I squared, and I squared is simply negative 1, so we're going to have a negative 1 there multiplied by this negative which is outside there, and we are going to have 1, meaning I to the power 4 is equals to 1. Okay, so what of I to the power 5? I to the power 5, we simplify using the same method. We say I to the power 4 multiplied by I is the same as I to the power 5, meaning I to the power 4, we already know that it is 1 there, and then we're going to replace where there is I to the power 4, it will be 1, and then multiplied by this I here, we are going to have our I here, so this will be I, not 1. So 1 to the power 5, I to the power 5 is the same as I. That is the answer. So I've simplified that. Okay, so from there, from the same method, we now know that I to the power 4 raised to the power 4 is equals to 1. Meaning, if we have I to the power 4 raised to some power n, then it will be just that, it will be just 1 to the power n, which is just 1, because 1 raised to any number, it is just 1. So I to the power 4, we know that it is 1. Now that 1 raised to the any power, it will be just 1. So for any integer, n, and n should be positive. Thus, it is now possible using that method to evaluate powers of I by factoring out for I to the power 4. Okay, hope you have gotten the method there. So let's now simplify I raised to bigger numbers, like big integers, like, so simplify the following. We have I to the power 48. I to the power 48. So we're going to use this same method. What we do first here is that we say we get the power, which is 48, then we divide this power with 4. So if we divide this power with 4, we are going to have 4 into this 48, it will be just 9, meaning 48 is equals to 4 times 9. Okay, so we are going to raise I to the power 4 times 9. So I to the power 48 is the same as I to the power 4 times 9. And we know that I to the power 4 is 1. So 1 to the power 9, this 9 here, it will be just 1, meaning I to the power 48 is the same as 1. The second question is saying I to the power 49. What of I to the power 49? So I to the power 49 is the same as, so what you do, you divide 49 by 4. So 49 by 4 divided by 4, it will be 8. 8 remainder 1. So we are going to have a remainder 1 there. So if you have a remainder, what you do, you simply add it. So it is going to be 4 times 8 plus that remainder, which is 1. So this part here, we are going to have 4I to the power 4 multiplied by that 8 outside. So where there is plus, we know that if we add, let's say we have x to the power a multiplied by x to the power b. So if we have something like the bases are the same, so to simplify this, we simply add the powers. So where there is addition of powers there, just to know that we had a situation like this, where we have the two bases which are being multiplied raised to some powers there. Okay, so that plus 1 here, it will be just I to the power 1. So any number raised to the power 1 is the same as that number. So for plus 1, it will be just I. And then this I to the power 4 is just 1. We know that it's 1. So that 1 to the power 8 there. So it will be 1 to the power 8 multiplied by that I there. And then we are going to have our I as the answer. And then from there, question number 3, which is I to the power 86. I to the power 86, you divide 4 into 86, it is 21, and then the remainder is 2. So the remainder, you add it there. So I to the power 4 is 1. I to the power 4 is 1. 1 raised to the power 21. And then this remainder here, you also, it is a power, so it will be I to the power, that remainder which is 2. So I to the power 2, we know that it is negative 1. It is negative 1. Here, I to the power 2 is equals to negative 1. So we are going to have negative 1 here multiplied by 1 to the power 21. So our answer will be 1 times this negative 1 there to be just negative 1. So I to the power 86, it is just negative 1. So that's how to simplify I raised to any power. So thank you very much for watching. Don't forget to like and leave out your comment in the comment section, as well as subscribing to this channel so that you don't miss any of my videos.